Hello and welcome to this clip on how to construct formulae from ions, one of the key skills at the start of your A-level course. This clip covers how to use the charges of common cations and anions to deduce the formula of the ionic compounds they form with one another. So basically what you're trying to do is to find the lowest common multiple of the ratio of the ions. So for example, if you look at the magnesium bromide, you can use the Crisscross method. So what we're looking at is we take the charge of one and we make it the number of atoms of the other, or the number of ions of the other. So what you're trying to achieve in every case is the overall charge must be 0. In other words, it takes 2 bromide ions to overcome the charge of +2 of 1 magnesium ion. So you take the charge of one ion and multiply the other ion by this number. Ignore the signs like minus or plus. You solve the problem. So it's absolutely essential that you make sure you memorize all of these ions, because if you're having to waste time thinking about what they actually are in an exam instead of applying them, then you're going to run out of time on questions. So these are simple facts, these ions. You just need to remember their charges and then be able to apply their charges to work out the formulae of the compounds that they form with each other. Now there's some provided at the bottom, and they'll be on your ions list that you've been given as well. It's better to be able to work them out from scratch, like this video is about to show you, rather than have to memorize them in terms of the compounds. So the cations and the anions list at the top of the screen are what you need to memorize, so you can then work out for yourself what the compounds they form might be. Some examples of which are given at the bottom. So the next thing to do is to get this table down. Now I'd suggest getting a piece of paper, a fresh piece of paper, and laying out the table like this, and seeing if you can name as many of the ions as you can correctly. So you'll need to go back to your ions list, a sample of which was on the previous screen, and maybe go away and do some memorizing. So the way you'd memorize is using the special technique called look, cover, write, check, repeat. So let me explain a little bit about what this means. First you look at what you're learning, either in your textbook or in your notes or in a summary of your notes that you've done. Then when you're ready, i.e. you're confident that you have remembered what you're learning or what you're trying to memorize, cover it up or you turn it over. Then you write it out exactly as it was on the piece of paper or the textbook page you were learning. You then check if you've got it exactly right, and you repeat it until you do get it right. Yes, it can be time consuming, but I'll tell you something, it really does help your understanding, because what you won't be wasting your time doing is trying to remember, because you can't. You'll be able to remember automatically. So what you'll be spending your time doing is applying your knowledge, and that's key to A-level chemistry. If you're able to do this and use this technique to learn the key facts that you'll be taught or you'll be asked to go and look up, that will make you so much better a performer in a classroom, and most crucially, so much better a performer in tests and exams. So what I suggest is we try this. If you grab your ions list, pause this video, see if you can memorize as many of them as possible. I'd suggest using about 20-25 minutes. After about 25 minutes of hard work like that, the brain starts to go off the boil a little bit. So for about 25 minutes, see if you can memorize by look, cover, write, check, repeat. Try it out, then come back to this screen, so pause the clip, and then see if you can write down the names of these, and the next screen will give you the answers. So pause the clip, come back in a little while and see what you can do. So hopefully you did reasonably okay. You might have missed a few. The ones you need to be careful of, the chloride, bromide and iodide ions, they are not chlorine ion, bromine ion and iodine ion. Very, very, very common mistake. They are chloride ion, bromide ion, iodide ion. There's a few others that you might come across later on in the course, but you don't have to memorise them at this particular point in time. You'll come across them as the teaching proceeds during the course. So it's really important that the ions that you wrote down, the names, are exactly as they've been written here, no different. So for Na+, for example, don't just put sodium, it must be a sodium ion. Okay. As a final footnote, some of them have Roman numerals after them because that particular atom or ion can take more than one form. In other words, it can take different charges. But we'll come across that later in the course as well. This clip is mainly about just learning how to remember the common ions. It's important to note as well that this isn't an exhaustive list. This isn't the only ones that you'll actually happen to come across. There are others as well that you'll come across. It just isn't room to put them all on this particular screen. But if you can remember the main ones like these, then the ability to remember the others as they appear on the course will become much easier. So let's have a look at the Crisscross Method, see if we can practice it a little bit, and then we can have a go at some. Lithium has a charge of 1+, so you need one oxide ion. And oxygen in the form of an oxide ion has a charge of 2-, so you need 2 lithium ions. So in this ratio, the overall charge per formula unit is 0. So this is what you want every time you construct one of these formulae. You want an overall charge to be 0. So same idea for magnesium bromide. Magnesium has a charge of 2+, so you need 2 bromides. Bromine in the form of a bromide ion has a charge of 1-, so you only need 1 magnesium ion. And so in this ratio, the overall charge per formula unit is 0. And it's the same story again for aluminium oxide. So aluminium has a charge of 3+, so 3 oxide ions are needed. Oxygen in the form of an oxide ion has a charge of 2+, so only 2 aluminium ions are needed, meaning that in this ratio the overall charge per formula unit is 0 yet again. So every time what you've got to check to yourself is, have you got the smallest whole number ratio needed for the charge of the whole formula unit to add up to 0. So let's pause for a second and clear something up. You may be thinking, why am I talking about formula units and not just molecules? So essentially what you end up with is a 3-dimensional arrangement where positive and negative ions alternate, with each positive ion surrounded by negative ions in all 3 directions, and each negative ion surrounded by positive ions in all 3 directions. So in this structure we don't get individual molecules, we just get ions arranged in a lattice. And the size of that lattice is only controlled by the size of the crystal it eventually forms. So you might have seen small crystals, and if it's a powder then it's obviously very small crystals. If you let a crystal grow over several weeks, you may have done this in school before, you can see that crystals can grow very large indeed, so that will contain a very large lattice. So we use the formula unit as a way of getting around this because it's the smallest ratio of each ion required for the overall charge to be 0. So that's what we're trying to achieve when we draw or construct a formula from ions for an ionic compound. It's the smallest number of each ion that we need to allow the charge to be 0. Just to recap on the way the structure is put together, each positive ion is surrounded by negative ions in all 3 directions, and also vice versa, for the negative ions being surrounded by positive ions in all 3 directions. So therefore that arrangement in itself doesn't limit you to one particular molecule, so you have to deal with the idea of no molecules in an ionic lattice in a different way, so we refer to formula unit instead. So it's based on the charges and making the charge 0. So here's some for you to try. Grab a piece of paper, copy these down, pause the video and see if you can work them out for yourself before coming back and seeing if you got it right. Use exactly the same technique as we used in the 3 examples in the previous screen. If you can't remember how to do it, rewind, go and have a listen to it again, and then come back here, pause the video and see what you can come up with. So, in the case of aluminium nitrate and iron sulfate, when you're dealing with anions that have more than one atom in them, these are called oxyanions because they invariably contain oxygen as well. You put the oxyanion in brackets, So hopefully you got CaI2, Na2S, AlNO3, 3, PbCl2 and Fe2SO4, 3. So it might be worth now trying a few other random ones yourself. Try 5 new ones and then bring them into class perhaps and have them checked. Or you could bring it to a subject extension, have a chat with your teacher and see if you're in agreement with yourself, your friends. But basically practice this and you'll find that every time you try it using this technique you'll end up with the right answer. So it's a nice sort of shortcut to helping you find what will actually end up with an overall zero charge. So again, to remind you, you're looking for the smallest whole number ratio needed for the charge to add up to 0 for the formula unit. So the formula unit would be PbCl2, for example, or Na2S, just to take 2 examples we've just done. So key points to remember: overall charge of the compound must be 0. The lowest whole number ratio of the ions must be applied. And to do this, you multiply each ion by the number charge of the other and then ignore the signs, and it gives you the ratio. So remember, it's the smallest ratio of the ions that you want that allows the charges to add up to 0. So if you have any queries about this technique, do jot them down and bring them into class and have a chat to your teacher, or come and see one of us in subject extension at college. But in the meantime, thanks for your time and see you soon.